periodic table and atomic arrangement. A number of you have asked questions about how to set up a Bohrs model and how it relates to the periodic table. This short presentation will go through how the Bohrs model representations of atoms will relate to the periodic table. So a little bit of review: the atom, the basic atomic structure. The center of the atom is called the nucleus. There are positively charged particles in the nucleus called protons. There are particles in the nucleus with no charge called neutrons. And these two particles make up the vast majority of the mass of an atom. Electrons are very, very small compared to protons and neutrons, therefore they do not have very much mass. The negatively charged particles that surround the nucleus are called electrons. Energy level number 1 around the nucleus can hold up to 2 electrons. Energy level number 2 can hold up to 8 electrons. And energy level number 3 can hold up to 8 electrons as well. We do have energy levels outside of 3. However, for this class we will not get into anything further out than the 3rd energy level. A quick breakdown of the periodic table. The groups. The groups are made up of all of the columns. So each group contains all of the atoms in the periodic table below it, or above it for that matter, I guess. So here is some examples of groups. Groups 1, that first column. Group 2, the second column. Group 3, the third column. And we continue on throughout the periodic table. The periods are the horizontal rows that occur in the periodic table. Number of valence electrons, and this plays into us setting up our Bohrs model. Each group has the same number of valence electrons. So group number 1 has 1 valence electron. Group number 2 has 2 valence electrons. Group number 3 actually jumps all the way over on the right hand side of the periodic table. You can see where it would be column number 13. That would be the group that has all of the 3 valence electrons. Everything else in the middle has varying numbers of valence electrons. Column number 14 has 4 valence electrons. Column number 15 has 5 valence electrons. 16 has 6. 17, 7. And 18 has 8 valence electrons. Therefore, group number 18, the noble gases, those elements in the periodic table are all completely full in their outermost valence shells. Therefore, they do not like to bind with other materials. So the Bohrs model. This is a quick review from the worksheet that you guys have. The Bohrs model, it shows all electrons. And in this case, we're looking at a silicon atom. The last energy level in an atom is called a valence shell. Electrons in the valence shell are called valence electrons. So it's kind of like us being in Fulton schools, therefore we are Fulton students. The valence shell contains the valence electrons. The center of the diagram lists the number of protons and the number of neutrons, instead of drawing them out as individual particles. So how do I find the number of protons, electrons, and neutrons for the Bohrs model? The atomic number found in the top for each of the elements, top of the box for each of the elements, it contains the number of electrons and the number of protons. So that 7 for nitrogen represents the number of electrons, and it also represents the number of protons. Remember that the number of protons does not change for a given atom. If there are 7 protons, the atom is always nitrogen. The N in the middle is the symbol or name. And then the bottom number, which is usually a much larger number, is the atomic mass. And that's basically how much the entire atom weighs in atomic mass units. So atomic number gives the number of protons and electrons. So it's given to you. In order for us to find the number of neutrons, we must subtract the atomic number from the atomic mass. So atomic number, atomic mass, and we're going to look at that on the next slide. So finding protons, neutrons, and electrons, here's an example of how to do that. We're still looking at nitrogen. Nitrogen has an atomic mass of 14.01. So atomic mass 14.01. The atomic number is 7. So I take the atomic mass and I subtract it from the atomic number, and that gives me 7 neutrons. We rounded that 14 back to 14.01 back to 14 before we subtracted, giving us 7 neutrons. Remember, the atomic number gives us the number of protons and electrons. So there are 7 protons and 7 electrons. So when writing out the Bohrs model, our 7 protons get written as 7p. Our 7 neutrons get written as 7n, and this makes up the center, or what would be in the nucleus of the atom for the Bohrs model. The 7 electrons will come in those shells around the nucleus. The first shell, remember, can only hold 2 electrons. So our first shell has 2 electrons. We no longer have 7. We've taken 2 away, so now we have 5 left. Remember, our second shell, it holds 8 electrons. And in this case, we have 5 electrons left. We can use all of those 5 electrons in that shell. We don't have more than 8, so all 5 of them can fit. So this is what our Bohrs model would look like for nitrogen.